All right, guys, these are your notes on the scientific method. Please remember that you have a quiz and it is an open note quiz, so make sure you get a 100. You only get one opportunity on the quiz today. So come back to these notes. They're available on Moodle as well as there's a link to them in your boss. So make sure that you have those ready to go. Okay, so these are the notes on the traditional scientific method. There's all sorts of ways that scientists investigate, but this is for experimental investigations. This is your classic scientific method. So we start with a problem, we go to a research. After we research our problem, we create our hypothesis. And then we determine what our experiment and our variables are going to be. We record our data on a data table and create a graph to summarize our most important data. And then we create a conclusion. And so we're going to look at all of the parts of that today. It's also important that you know that usually the conclusion is not where it starts. The conclusion usually makes you decide that you want to do the experiment again in a slightly different way, or maybe it makes you think of a completely different problem altogether. So we kind of start over with this whole process back to the scientific method again. So let's look at the things that you need to know the most about the scientific method. So your first two steps are your problem and your research. A problem must always be testable. It's something that you can create an experiment about. And your research should be about that problem, and it should be designed to help you create a solution. So down here you can see an example. So the problem is, what type of paper is best for making a paper airplane? And a research that you might do would be research on different kinds of paper, like what they're made of, how much they weigh, things like that. So you can definitely test the type of airplane by making the same kind of airplane with different pieces of paper. And you can do research about that prior to creating your hypothesis. So a hypothesis is a predicted answer to your problem along with the predicted outcome of your experiment. A good hypothesis should be based on research and include appropriate scientific terminology and in formal experiments, it should be an if-then statement that reflects on variables. And so down here, this is a quick hit on how to make a correct hypothesis. You're going to need this when you do your experiment later on next week. So your if statement on a hypothesis is the predicted answer to your problem, and the then statement is what the data will look like if your predicted answer is correct. So if you think that construction paper is the best material for a paper airplane, then the construction paper airplane will fly farther, right? So that's what the experiment says here. So if construction paper is the best material for paper airplanes, then paper airplanes made of construction paper will fly farther than airplanes made from notebook paper. So it's just what your prediction is, as well as what you think your data is going to show. All right. In your experiment, it's important that when you plan your experiment, you are thinking about your variables. There are 3 sets of variables: the independent variable, the dependent variable, and the controlled variable. So these are probably your 3 most new vocabulary words. Maybe not, but these are the things that usually students have the biggest problem with. So I'm going to give you a couple of hints on trying to identify the independent, dependent, and controlled variable, and they all have something to do with the beginning of the word. So the I in independent, the D in dependent, and the first word control in controlled variables. All right, so let's look at this. Okay, so your independent variable is the thing that you change. So I change the independent variable. The dependent variable is the data that you gather. So the data you're recording in your data table is really going to be your dependent variable. And the controlled variables are quality control. So when you are doing the experiment that we're talking about with the paper airplane, you are going to change the type of paper that you use. So you're going to make one with notebook paper and one with construction paper, right? You're changing the type of paper that you use. So that's the independent variable. The dependent variable is what you're measuring, right? The data that you're gathering is how far they fly. So the distance flown then would be the dependent variable. In order to make sure that it's just the paper that's being tested and not anything else, you want to make sure that you're flying the paper in the same room, you're flying it with the same way, like you throw it the same way, that you make the same paper airplane design. All of those things are quality control, right? Because if you change those things, then the independent variable, the type of paper, might not be the only thing that's affecting how far it flies, right? So controlled variables are all the things that you keep the same in order to make sure that the quality of your experiment is dependable. So it's your quality control variables. All right, so once you have determined what those things are, you've determined your independent variable, you've determined your dependent variable, you've determined everything that you need to keep the same and laid out your experimental plan. You need to figure out how to make a data table to gather your data. So one of the things that students also kind of get confused is confusing a data table with a graph. So a data table is a table. It's where you collect your data. It's all the data that you collect, okay? Notice here I've got 3 trials, right? You want to make sure that you do multiple trials if you can, because that also helps with quality control. So if you accidentally throw it bad one time, you can throw it 2 more times and take the average, and that will help with your quality control as well. So your data table collects every single piece of data that you gather. It's really important that if you have multiple trials that you also have averages, because you want to communicate the most important data, and your most important data, so in this case your averages, is what's going to go on your graph. Okay, so your graph is either going to be a pie graph, a line graph, or a bar graph. Most of the time in science we use bar graphs, sometimes line graphs. Most of the time in math you use line graphs. And that's because quantitative numbers, or quantitative data, which is number data, is along the x-axis and along the y-axis in a line graph. So when we're looking at numbers for both things, you're going to use a line graph. But usually in 6th grade science, there definitely are exceptions to the rules. We're looking at equality, and we're looking at numbers based on equality. So we're going to make bar graphs most of the time. So for example, your quality is what the paper is made of, like construction paper, right? So construction paper isn't a number, it's a quality. So you would put construction paper, this is how far the construction paper one flew, this is how far the notebook paper one flew, and this one is how far maybe the computer paper flew. So this is qualitative data along the bottom. So this is representing each one of my qualities of notebook paper. And then this is the quantitative on the y-axis, the number, the distance. So we will have at least one number, but not always 2. All right. So whenever you create a graph, it's important that you label it properly, and that you put the right information on the right axis. So your y-axis is your up and down axis. And your x-axis is your horizontal left and right axis, okay? So these things kind of help you to determine where they go. Dry mix helps to tell you what axis, what information goes on what axis. So D is dependent. Some people also call the dependent the responding variable, and that goes on the y-axis. So this is the y-axis. If you were creating a paper airplane graph, the distance is the dependent variable, right? It's the data you're gathering, so it will go on the y-axis here. Mix stands for manipulated or independent. So our independent variable is the type of paper. So you would make a bar for each type of paper, right? And that goes on the x-axis. So that's what the x is. So dry mix helps you to remember which axis you record your data on. Tails is just talking about that you need to have a title, that you need to have axis labels, that your interval needs to be correct, that your labels and your scale need to be correct. So we'll talk about that a little bit more when we do our own lab. But that is a great resource for you, and there's also a copy of it in your BOSS. Whenever you create a conclusion, you always need to restate your claim. You need to summarize your evidence, right? Summarize your data, tell me why your claim was correct, why or why not, and then give me that scientific reason. So these are your guidelines for creating a good conclusion. It tells you what the important part of your claim, evidence, and reasoning are. Your reasoning includes why did your results turn out the way that they did, what scientific concepts were covered, and what new questions does this pose. So that is it. This is an article about the scientific method. We're going to watch this video in class today, and then this is another video for you guys for a resource. So these are all here for you to watch again if you want to visit them later. But that is about it, guys. I hope this was a helpful video.